So without further ado, I'm Kristen Toll, and when I organized this panel, I used to be with Microsoft Research. But this actually turns out to be a benefit that I'm now actually with Microsoft in the data science group. And my job actually is to train everybody in the world on data science. So I'm no longer limited to just the academic sense and the outreach that I was doing inside of MSR. But now I have to think about the world. So if we're thinking about what Satya was saying earlier about displacement, this is I'm the throat to choke. With me today is actually Rob Marsari. And so while I've been a very externally facing person, I invited Rob to join our panel today because Rob represents the inside of Microsoft, somebody who's actually running a data science team that helps us make sense of the mountains of data that we have inside of our organization. I've also invited Magdalena Balazinska, who's actually from the University of Washington. Sorry about that, Magda. I've known her forever, and I did that. But she's one of my colleagues, actually, at the E-Research Institute at University of Washington. We also have Kathleen McCowan, who's with Columbia University. I was very fortunate to be there at Columbia running a data science student challenge last November. It was our very first one that we did. Great time engaging with the students there. And Joshua Bloom, who's a friend of my skip level manager, Vijay Naranyan, who is joining us to, I wanted to cover coasts. I wanted to make sure that there was diversity on the panel. And I also wanted to make sure that we had a diverse group up here that you could ask questions of. And I am hoping for this to be a very lively session. That said, I know how panels can be, and I know that you have to get the audience warmed up. And so I've come with questions just in case there's any lulls in the meeting. And I'm going to go ahead, but there is a Microsoft runner, is that correct? Great, he's actually back there. And another one in that side of the room. So if you want to ask a question of the panel, do raise your hand. So in the program, I put several questions in there I had, and I'm going to start with walking through some of those at first. So for instance, what I'm wanting to know from our educators here on the panel, how are they coping with the exploding needs for data scientists? As now somebody who's hiring, and I'm struggling as an employer, I'm sure Rob can second that. We're curious to know, for instance, what are educators doing to help supply our needs? Because I can tell you right now, there's probably about 80 open requisitions for data scientists at Microsoft. And I'm sure every other big data company in the world has a similar number. So Magda?
Good. Thank you. Can you hear me? At the University of Washington, already many years ago, we came to realize that every single student on campus needs to be educated in data science, because data science, from our perspective, and I think many people share that perspective, is not something special on the side that should be in its own separate department, but it's something that everyone needs to know, because that's the way the world really is in pretty much all the disciplines. So to address the question of how we are therefore dealing with the fact that we need so many new data scientists, we consider that we need to educate every single student in data science at the undergraduate, master's, and graduate level. So what we did is one initiative at each level. We wanted to make sure that no department does something separately on their own, because all departments need to do something. So we actually got together through the eScience Institute under the umbrella of the eScience Education Working Group. Everyone is invited. It's a completely open working group, so all interested departments send representatives, different faculty from their departments, and we work together on establishing new initiatives at different levels. So if we start from, let's say, the graduate level, that's where we started, we said if we want our PhD students, those who, no matter what department they come from, they want to really push the boundary, the state of the art, and build new data science tools, for them we created what is called an advanced data science option, where students come together and take advanced classes in data visualization, data management, statistics, and machine learning, of course. We also have now, we are introducing a complementary data science option at the PhD level for those students who will not necessarily create new tools, but really need to learn about these tools. At the master's level, we have a new program in Masters in Data Science that is starting this fall. And at the undergraduate level, we also have an undergraduate data science option that similarly is meant as a specialization for students in various departments to really learn about these fundamental data science methods and tools in the context of their specialization. So I'm just going to say all this, otherwise I can talk for half an hour just by myself. So let me stop here, but that's our basic strategy.
Okay.
Okay, so we have several programs that we've launched at Columbia. We are coming up on our third year for our Masters of Science in Data Science, and we have quite a bit of interest. We had around 1,000 apply, and we will have about 120 in our entering class in the fall. So the Masters has foundations in computer science and statistics. Data visualization is part of that. And then afterwards they can do tracks in any of the disciplines which they're interested in. And this has been one of the big focuses of our program at Columbia, which is really outreach and inclusion of all of the schools across campus. So in these tracks, they can look to pair with really courses from almost any department across campus. And if I look at our incoming students, I also see more diversity than I actually usually see in computer science. So we do look for people from a quantitative background, but we have people coming in from all different areas. Economics, we had an MD in our last program, and our representation of women is higher. We have 36% women in our incoming class at the master's level. We also have a certificate program, so for people who are working and they want to shift in their job and learn enough data science so that they can work, that's an option. We're working on a PhD, and we expect that to come online probably a year from this coming fall. And then we have some courses which we hold for non-technical people in data science. So we have an introduction to data science, which is at the graduate level, but it's intended for people who are interested perhaps in issues around policy, privacy, ethics, and so forth. We are starting an undergraduate in data science. This draws on our previous major, which was computer science and statistics. And then finally, we have a program at the school which we're just planning to launch this next year, where we opened it up for faculty across campus who want to work in pairs. So people from the more foundational areas of data science with people who have data, and they want to be able to teach students how to learn how to work with it. So we expect to have several interdisciplinary classes in the next year.
Great.
So this need that people felt for filling up the pipelines for industry and academia was satisfied in the grand spirit of how UC Berkeley usually does things, which is completely decentralized and very hodgepodge. For a number of years, we've been running seminars and boot camps, having students teach students after hours in some of the different tools and techniques. And it's only in the last several years or so have we been able to really get a concerted effort across campus. And in particular, we started with a effort at the master's level. So the iSchool, for instance, started a master's program. We also had something in computational science and engineering called a designated emphasis, again, focused on PhDs. And only just in the last basically year or so have we been able to get at the chancellor's level of interest a set of statements about the importance of data science. And I think in a provocative way, what the chancellor has said is that the 2020 vision for all of our undergraduates is that they would be proficient at telling stories with data and understanding analysis of data by others. And so it's a strong statement that UC Berkeley has made for their undergraduates that this data science thing, and we can spend some time talking about what that actually is, should be infused in the core of what every single student in this country needs. And so in particular, we kicked off a program called the Foundations of Data Science, which was intended for first and second year students. And for those that are interested, there's a website called data8.org where the course material exists. The first instantiation of this was last fall, and now, as of last spring, we had about 500 undergraduates taking it across 52 majors, with a 42% representation of women in that class. And that was seen, given its name as foundation, as the foundation for essentially a launching off into data as a central part of an undergraduate education. So we've created things basically that we call connectors, which are classes that are taken concurrently in a number of different departments, from biology to statistics to history, ethics, et cetera. Then there's extenders, where basically these are deeper classes in all these different disciplines that build upon the foundations they've learned, with the eventual goal, and whether this happens this upcoming semester or in a few years from now, of creating an actual data science major. And then, of course, we need to define what are the course concepts behind that major. So it's very much a work in progress. We feel like we're making a lot of headway.
Yeah, it's interesting that you're at different stages, and you've kind of lined up that way too. I noticed, but actually, I know that when I was on the other side, now I'm on the Microsoft side of it. In fact, Rob, so this question is going to be directed at you.
Okay.
But it's really Josh's fault that I'm asking you, because he said, what is data science? And I think there's kind of a misunderstanding about that in general. I mean, in my mind, data science has been around since before Kepler. So I don't really think of it as new or hot or special. I mean, it's old news to me. I've been a data scientist for probably 22 years now. So for me, it's like, yeah, it's just a new moniker for a new thing. But one thing that has changed is the way industry interacts with data. And so when you think of the ideal candidate coming out of one of these programs, could you describe how you think that person,
Sure.
what their skills are?
Sure. So I'll talk about that maybe in the context of the data science practice that we run in the Windows and Devices group. So my team is a shared resource of data scientists and data engineers who partner with the engineering teams across the division, the engineers who write the code in Windows and the browser, who work on the Surface hardware and HoloLens and the Xbox consoles, to help create insights to better answer questions around the product, the engineering system, and the business. We run a practice that we've kind of formalized because we serve so many engineers in something we call the Insights Factory. And the Insights Factory is a way of onboarding new projects and then managing those projects through a life cycle. And I'll use that life cycle to relate to how we think about data science talent. Each project is onboarded, and the initial phase is typically one of framing the problem, the question, creating hypotheses that could actually be tested through data and analysis. And so there's a skill set there that we look for when we're talking to candidates around being able to, take a problem and turn it into something that you could actually pursue and answer. The next stage of a project is typically assessing and gathering the data that could be used to answer such a question. And the skills there, and as any practicing data scientists know, you spend 80% of your time actually preparing the data, cleaning the data, readying the data. And so there's a set of skills that go along with that. And in our case, we're dealing with very large data sets, largely telemetry data or customer feedback, petabytes of data. And so there's a set of tools and skills that go along with that you're probably familiar with. We have some of our own proprietary ones. We use lots of open source ones that you would know. And then of course, there's the actual analytical piece. And that ranges for everything from, simple descriptive statistics to applied machine learning to other analytical methods and computer science methods to generate insights from that data that hopefully can be used to apply to tell a story, and then to create action and outcome and changes in the product. Because in the end, my team is assessed not on data science papers that we publish, although we do publish papers from time to time, but on the impact and changes that come into the product through the work. So there is this whole storytelling component and bringing the engineers along and grounding it in the customer impact that the work can have. So that's how we think about it.
Okay.
So if I could add to that, so I also benefit from having started a company that's doing AI for CRM. It's called Wise.io. And in our hiring practices, what I will say, and we were supposed to be controversial here, so here's my first one. What I will say is that if it's got the word data science on the resume, I get very skeptical. And the reason being that what's worked for us, and I suspect works for Microsoft as well, is not to hire generalists who are good at that entire life cycle, but instead to hire individuals who are very deep in a part of that, yet know how to work with others. I mean, I think data science is a team sport, right? And I say that there is no such thing as a data scientist insofar as somebody who can push the envelope on all of these different realms. There's a sort of semi-famous quote, at least in the astronomy realms and physics realms, around data science of this imperative to create these so-called pie-shaped people. I don't know if anyone's heard of that before, but if you think about what the pie looks like, right, it's sort of two very long legs with a connector on the top. The idea being that you need to get somebody who's incredibly deep in a domain and somebody who's also incredibly deep at, say, some aspect of machine learning to be able to get into the black box and fix it and do some novel things with that. And instead, what I think, the way I think about it is what we need to do from an educational perspective is hire gamma-shaped people who are very deep in something and maybe a little bit deep in a few other places. So for those, I guess I'm drawing it backwards for the audience. And it depends upon your font choice whether you get that little other piece. But getting a bunch of gamma-shaped people together is, I think, where the best results wind up coming out.
So we think a lot about pairing people so that you don't have to, you probably can have people who are experts in both, but if you put people together, they learn from each other. The people on the data science side learn about the domain and how that changes their tools, and the people on the domain side can begin to learn some of the tools so they can do some of it themselves. But I'll be controversial too. I think your answer is contradictory. How can you have a program for educating people in data science and on the industry side say you're not going to hire them?
Oh,
no, that's
wow.
great. No, and I live with that controversy all the time. What I think is important to recognize is that we have to think very hard about what the educational mission is, what are the goals at the undergraduate level, so that we're not producing just a bunch of generalists who are going out and putting data science on their resume and then not having a deep impact in industry. But we need to prepare them to be able to have those pairwise conversations with others. As an individual winds up going out and becomes a great machine learning expert, to be able to work with somebody who's a cryptographer and very deep in that, to come together and do something completely novel. We have to teach people how to talk to others in these other sort of adjacent realms. So I have comfort with that. And again, if you just agree that data science is a nice buzzword that attracts money and attention, and that you can add a moniker on top of a number of other efforts, I think it's very useful.
So I'm going to both agree and disagree with I guess, Josh. And the main thing I'm going to disagree with is that, yes, I strongly agree that we need to produce people who can talk to each other. So in all our programs, students are required to participate. Either they have to take the same classes or they have to participate in our eScience community seminar where the whole community comes together. They have to work together. Yes, this is important. But if we don't educate people in data science in a deep way, so we want someone who knows enough data management, enough machine learning, enough statistics, enough data visualization, that they are no longer kind of the naive collaborator, but they have to be an expert collaborator. And I think what we need is same thing for people who are already experts, maybe in machine learning and other aspects. They have to know enough of the domain sciences that the conversation can start at a deep level. Otherwise, we're going to always spend 18 months talking to each other before people understand what the others are saying. I don't want those kinds of collaborations. What I think we need is people who, coming from their undergraduate degrees, already know enough data science to put data science in the resume, because that means they have a deep foundation. They are pie-shaped. They have a deep foundation in these different aspects of data science methods. They have a deep foundation in their selected chosen major, which could be a method or a domain science. And therefore, going out there, they can collaborate with people directly at this deep level as opposed to this shallow level.
I'd like to say that it's funny. We've heard gamma shape, we've heard pie shaped. So in my organization, I like that you wanted quick, Magda, because in my organization, our responsibility is to also build proof of concepts for our customers, our enterprise customers specifically, who come to us. And we have a long-term project to us is 2 months. And expert collaboration is absolutely necessary, because in our data science, what we call pods, we will have in there someone who's very deep in the machine learning and predictive analytics, someone who's really excellent at the engineering aspects of it, another person who's really awesome at communicating out. In other words, not even within the team per se, because we assume that all 3 of them can communicate with one another. But being able to then describe to a customer, because you want to teach them to fish. You don't want to just keep having to throw fish over the wall. We don't want to actually do multiple ones with our enterprise customers. We just want to do one with them, and then let them take the knowledge that they learned from us working together with them. So what we also do is ask them to bring a pod, and then you can imagine 6 people working collaboratively together, 3 from the actual company, 3 from Microsoft, working together. And we've just introduced a 7th member of that team, and that person is the trainer. Because once maybe the company themselves doesn't have a notion of a train-the-trainer program, but we do have the notion of a train-the-trainer program. So that person then goes with the 4 that come from the company, goes back to the company, and then educates his peers on all that he learned. And so that they then can truly learn how to fish from there. I just thought I have a different dimension on it. So I think of it as a circle, a pod, gamma, pie shape. But I think no matter what the shape, it really comes down to the fact that you need these 6 people, or 7, as the case may be. In the next month, we're going to roll out the 7th. All of these people need to have excellent communication skills above all else. If you're going to go into an office and do brilliant work, you're in the wrong job. So I'm going to, I lost my questions. If there are questions while I pick mine up, if anybody wants to ask a question on the panel, please do. If not, I'll go to my next question on the list.
Hi, Philip Guo, University of UC San Diego. I have a question operationally about if the panel would brainstorm about what kinds of languages, tools, technology specifically you feel are especially in demand for data scientists in industry, and also what you're teaching the students. I would love to hear everyone's feedback about that.
I'll be quick, and then I'll pass it down, because Rabbi, I'd love to hear what you're,
Sure.
because you're in a totally different team than I am.
Yeah.
From my standpoint, R is the lingua franca of data science. And so most of the projects that we do are actually R-based. We're an advantage that Satya has actually opened the doors to open source. So we spent a lot of time using Microsoft R Open for some of the bigger data problems, we use Microsoft R. But a working knowledge of R from a student incoming into our group is very valuable.
Yeah, so I would echo that. For most of the work that the team does, R is a foundational tool. There is, I would say, a large contingent of the team that uses Python for much of the machine learning type work that we use, and especially if we're putting something into production, we generally lean on Python. We have a large data set that is in an internal proprietary store called Cosmos, which you could read about on the web. It's a MapReduce style store and processing environment with a Hadoop-like support and other kinds of languages. And so exposure to those kinds of environments would be important for our team when you're looking at candidates, because we know then they can quickly learn our proprietary environment because of the similarities there. And then, of course, we use the Azure-based HD Insight and Hadoop implementations. We use Azure ML and for some problem sets. We do still rely a lot on SQL in certain places for certain kinds of data, as well as Power BI and a bunch of the in-house data visualization tools that we have. So that's probably the core set of tools.
Do you want to talk about industry before we go into academia?
Sure, I can try to serve as the transition. I mean, one of the challenges or tensions that I think you've hit upon is that, you know, from a pure research perspective in a specific domain, say an astrophysicist, I'd want them to have a certain set of skills and proficiencies in certain languages. You know, I'm a Python person myself. But from a sort of pure teaching perspective, the goal is to teach people the deepest concepts that we can get into them at a stage appropriate in their career, so that it doesn't matter whether in 10 years from now they're using in Python or R or some other new language that's come around, they understand the core concepts. So I think part of what we're all struggling with is what are the core ideas, what are the core things that people need to know in this thing that we'll call data science, that specific languages or packages are just instantiations of it at the current time. But regardless, you know, in many years from now, those students are going to be able to carry that with them. So we have this tension between, you know, the almost vocational needs that we have of our students from a research perspective. And again, we're all representing research institutions where the research is a top priority versus the educational ones.
Yeah, so I guess I would think of it from both sides. We do look a lot at what principles and people should learn and know about when they come out. So on the statistics side, probability, statistical inference. On the computer science side, algorithms for data science, machine learning. Data visualization, of course, is important. And then we have a class on computer systems for data science, which exposes people to issues in the architecture of dealing with big data, in parallelism, in databases and distributed processing. So, you know, some of the tools that we heard about here today, like Spark and Hadoop, would be things that would be covered in that class. Typically, in terms of programming languages, R for the statistics class and Python or IPython for the computer science classes.
So I'm going to echo some of what is being said. And I think at UW, and similarly at other universities, what we try to do is have kind of at one level across departments agree on the main themes that we need to cover. So someone coming out, if they want to be productive in data science, they need, you know, some of these topics. They need to know how to program. They need to know how to tell a story with data, do data visualization. They need to know how to manage data kind of from small scale to large scale. They need to know how to build the models, right? Apply all the machine learning techniques, etc. So we have kind of at one level, we need to agree on what these common themes are. And of course, for example, data science and ethics, and then build our programs to make sure that we hit on these core topics. Once we do this, we're going to have the specific classes where at that point it becomes more the responsibility of the individual faculty to say, in this broad topic, these are the core concepts, and these concepts will go beyond the next few years. So there will be kind of lasting concepts. But then, of course, to illustrate each concept, it is most useful for the students if you can use whatever tool is being most prominently used today. So as an example, I'm going to give the introduction to database class that we have that we offer both to majors and non-majors around campus. It's a popular and large-scale class we offer 3 times a year, where we're going to say, okay, so you need to learn about how to manage data. We're first going to show you this, you know, the SQLite on your machine. Then you need to know how to use it at slightly larger scale with, you know, more kind of scalable tools. So we're going to show you the Azure cloud and how to use SQL Azure. Then we want to go even at larger scale. And here we have a lot of choices. Well, we've already showed them the Azure cloud, so we're going to now show them the Amazon cloud and how to use Spark on top of the Amazon cloud. And by doing this, we both cover the concepts of data management at different scales and also try to expose students to kind of important tools they need to know today. And these tools, of course, they change. So every year we're going to change a subset of the assignments because we always want to keep up and show them what will be useful when they graduate. And I think we always have to keep thinking at these three levels, like what are the topics, what are the core concepts within the topics, and then what are the specific tools that are useful today.
I'll come back to you. The two things that came up on this last question, in fact, maybe it was mentioned even earlier, but before I take another question from the audience, so obviously data science is a term that's undefined from the panel's position. But the other comment that you guys have made, several of you brought the concept of ethics. So how does ethics play a role in data science? What, do you teach ethics? I mean, do you not teach ethics? Do you think we ought to be teaching ethics? I mean, in my mind, when we think about the ways in which we cause the most privacy violations, it's the triangulation of data.
So I would love to take this question because at UW we think this is critically important. And it goes beyond ethics. We actually decided to call our seminar Data Science and Society because there are so many societal implications of data science, from all the good data science can do to all, of course, we've heard recently the terms responsible use of data, data privacy, ethics, etc. And there are kind of different levels. What we believe is most critically important is to make sure that all the students all around campus, as much as possible, are at least exposed to this notion. Everyone has to know what good data science can do, and they need to think about and reflect upon many different negative results of misuse of data or even unintentional consequences. We all heard about machine learning models that discriminate just because they kind of start and learn from data that is already biased. So our number one goal is to make sure people are sensitive to the issue, because if they are sensitive, then they will keep paying attention to it. And then I think so we mostly address this issue by making sure we have different seminars that students can participate in where they will get exposure to this. And I think the other second question is then how do we push and kind of deeply teach different aspects of data science and societal implications.
Yeah, I also think it's critical. We don't have a course on data science and ethics, but we've held a number of workshops where we've invited experts to come in and speak about this. I think it's an area also that engages people in the non-technical field. So we've had a number of people from the business school, from School of International and Public Affairs, and from the law school who are really involved in thinking about what the issues should be and how we should address them.
So I believe that ethics and data science is a connector back to the foundational data science undergraduate program that I mentioned earlier. But the way I would say it is, great question, should ethics be sort of in the canon of what is considered data science core? And should we be teaching that formally? Should that be a formal requirement? Should industry be helping us in saying, look, if you haven't had a class in ethics, you're at a disadvantage relative to the others that had? I mean, those sorts of things from industry would wind up helping the educational mission, I think. So knowing that this is central to what you all care about is very important.
Yeah, and from the point of view of our practice, customer privacy and protecting customer privacy is a critical part of what we do as an engineering organization in our products. And we train all our engineers who use our data to inform decisions on our privacy policies, and we have, of course, the right access controls and things like that in place for the data. But generally, we find we have to train it because it's specific to our policies and our practices. But having exposure to the fact that there's something to think about there in your application of data science, I think would be valuable for students to have.
There's a reason we have a proprietary big data system, because we take our customers' privacy so seriously that to use just anything that's out there would be unacceptable to us because of the surface area and the target that Microsoft has as a company. And if and given that is our really critical to our organization, it comes all the way from the top, that it is our mission to protect people's privacy. But The reason I asked too is when I was at Columbia, one of your students said to me, "I have no privacy, so why do I care about it?" It was a shocker for me, actually. I tweeted it, and then everybody thought I had said that privacy didn't matter. But what I was doing was re-mentioning something somebody said. So I want to clear the record there. I feel very strongly about privacy, but maybe some students who are joining data science programs, they aren't. But yeah, please go ahead and ask your question.
I'm Dominic from the University of Washington, and I wanted to ask a little bit more about this educating data scientists. So you said okay, I'll just talk loud. So the role of, or what a data scientist is not really well defined. But then there's this conflict between educating very specialized data scientists who are expert in visualization, machine learning, data management, and so on. But on the other hand, you want to educate a large number of people. So do you think a data scientist there should be very, very few data scientists who are experts, or should data science be something that is taught to every student? Where do you think we should be on the spectrum?
Okay, so I'm going to repeat that question since this is A, being recorded, and B, I'm not sure everybody in the room heard it. The question is, given that there's a demand for it and there are lots of students who want to do it, but then there's a lot of specialization within data science. Do we want to have a few that we consider the experts, or do we want to actually have a very broad program where we would basically teach it to everybody in the entire university? And so I'm going to go ahead and turn that over.
I mean, that question fits well within the undergraduate mission as well as the graduate mission from education. So the easy answer is it doesn't have to be exclusive. You can do both, in the sense that if your target for an undergraduate coming out of a program that is not in the sort of mathematical sciences or computational sciences, is to get them to be able to do computational thinking, be able to do inferential reasoning on data. And if they can do that well, then you call that the win, and get them broad enough with enough deep concepts that they can then go out into the world and do what they were doing in a completely different, potentially non-data driven work. That's okay. In fact, the way I would call that is an imperative around data literacy. And in my mind, that is what we should be doing with undergraduates. And the ones that catch the bug early on, if they're taking these classes in their first or second year, who decide they want to go deeper and deeper, will naturally wind up gravitating towards some of the classes where they can become that sort of proficient expert in one of these data science fields. And then as they go into their master's program and PhD program, they can get even deeper. So I think the role of the university in this data science world is to make sure that we're serving not one or the other, but both, if that makes sense.
Yeah, I would strongly agree with that, that we should have a program that really educates people who want to, this is their mission, this is what they want to do, and gives them all of the technical background that they need. But we should think about it the same way that we think about computer science and mathematics, that there's a certain level of literacy that everyone should know.
So I strongly agree. So at UW, our mission statement is data science to all the students, that all the students need to have this minimum level of data literacy of skills that they can be effective tool users. And the second point about specialization is actually, I think it's much more important for students, whatever field of study they have chosen, to be able to specialize and be experts in data science within that field as much as they want, as opposed to having to move them into a separate data science department. So I think all the students should have foundations in data science, whatever their field of study, and students who so choose should be able to specialize and be innovators in data science within their respective disciplines.
So a comment on that, we discussed this a lot. Was in Chris's team before she left. We discussed this a lot, and I just wonder whether we've already done this with statistics. It's the discussion around, should you teach statistics? You can do a PhD in statistics, but I taught aerospace engineering, and aerospace engineering people have to know about statistics so they can calculate whether you can design a structure that doesn't break down after a certain number of flight cycles. And so I think these discussions we're having I feel, has
Like we've
already
had
been
them?
done in statistics. And data science is it's a different field, but that sort of discussion of depth and T and all of those things.
So is the question, before you get the hand off time, is the question that we've already had these conversations around statistics, or is it just that it's that we're having similar conversations?
I think it would be interesting to sort of do the diff on the discussion. So do you just do search and replace statistics with data science, okay, in terms of designing programs and embedding it and those things? Or if not, what's then the difference between how we teach statistics, depth, breadth, programs, embed statistics in teams and have professional statisticians in teams? But, it feels like the similar discussion, and what's the similarity, and then what's the compare and contrast, I guess, is the
Fair enough.
So I would like to take this question. I think there's one major difference is the volume of data. So for example, everyone I talked on campus, everyone wants their students to learn data science. I think we all agree on that, which actually makes my job very fun and easy because everyone is already on board from the get-go. I think the key difference is how much do we need, how much content. If I talk about statistics, well, maybe I need to add 1 or 2 classes into a major, and then people are happy. When we talk about data science, I want to add a stats class, a machine learning class, a data management class, a data visualization class, and before we know it, we have 30 credits of stuff that it's so essential, and we want to add it. And I think this is the key difference, and that's why this is a new problem.
Hi, this is Mohammed Muqbil from University of Minnesota. So the discussion about data science, if I make an analogy with computer science, if I say a department offer a computer science degree, more or less I know the course structure. What does it take an undergraduate, first year, second year, third year, and so on. Data science, as we all see now, it's kind of vague. And it happens because of the rush. Everyone is trying to make their own data science degree now. So it becomes there's nothing standard here. Every data science degree is completely different, not completely, but big difference between them. And that's why maybe you are saying, if I see data science in a resume, I really don't know what does this mean. So do we need to make something like a well-defined course structure, like what is in computer science? SEM should play a role here. That's one thing. Looking at the future from now, do you think that we will have a department of data science as a department of computer science, for example? So it will be a separate department, separate college. And if this happens, what this creation would be? How do we hire, from where we hire?
So I guess I'd answer the first question that it's still very early days. And for those that have worked on standards in computer science, knows that it's very dangerous to define the standards and promulgate that from the IEEE level down too early. You let a number of different actors play out the way they think it should, and then over time, what the standard is will wind up evolving and to the point where everyone winds up agreeing. I think we're all doing our own sort of point particle experiments in our own institutions, as are a number of the other institutions that are represented here. And what we're going to wind up seeing is that what works in one institution may not work in another, but the commonalities that's going to emerge, I strongly believe, what you teach at the undergraduate level and what are the fundamental concepts, what are the connectors to the domains, those will all wind up coming out. And I believe in some amount of time, maybe on a 10 to 15-year time scale, it will be clear if data science is still around, what data science actually is and what the concepts need to be. So there'll be some level of standardization over time. I just think it's too early to do that now.
I think you do see a lot of commonality. I think when the three of us have been talking about what we offer, you've heard us mention a lot of the same things over and over again. And I think if you look at different schools, you do see a number of the same courses. So what is different, what seems to be different, is how we offer it. So, the difference between UW, where they will now have a master's degree, but it has been embedded within departments, versus what we have done, where we mostly have, as a program or as a degree, people can go into it. Now, we do offer courses that, because we see the need, again, across all of the university for people to get involved. I guess I really feel that people from different disciplines get involved in very different ways, and it's probably a good idea to have very different kinds of courses. And and ways for, so we have people in English who are involved in data science and people in history, and that would be very different from people in economics, for example, or people in physics.
So just a quick clarification for the records, our master's degree is a standalone degree. It's actually 6 departments that came together to have the standalone professional master's degree. The PhD and the undergraduates, because they are for our daytime students, we want to touch all the students. These are specializations within the degrees.
Rob, you were.
Yeah, my observations as someone who's on the other side of the point experiments that are happening and somebody who goes to campuses to interview and hire candidates. Over the last 3 years, I've seen a lot of change, and it's begun with like finding students in the computer science department who have had some coursework in statistics or machine learning or big data, things like that, 3 years ago, and they were few and far between, and it was largely expressed through a student who had particular interests, to, in the last couple of years, more formalized programs and training, and students that are showing up from other departments of transportation, biology, and physics, who, when they hear Microsoft is there to hire for data science, are coming to hear about those roles, and I'm finding them to be, well-trained, good potential candidates.
I also want to tack on to the first part of the question, since I can't really answer the second part of that question, although I do think that we should have a data science department, but that's more of an opinion. I think it would be worthwhile for us to have a DE examination, just like we have a PE examination. Professional engineering is what PE stands for, by the way. But I think that I would like to see some standardization. And I understand that someone could do an emphasis on specific areas below that, but it would be really nice if we could not look at data science on a resume and go, what does that mean? So I would actually take it a step further and say I would love to see us think about that. Maybe not just from the bottom up. I agree it needs to come both directions, but I do wonder if IEEE shouldn't be thinking about a data science special,
So I think
type
that
of degree.
I agree and I disagree. So I agree that it has to be bottom up, because since we don't really know what data science should be, we have to try, and then we have to change it, and then we have to try and change it. The way that we try to address the problem of actually defining what data science is so that it means something on people's transcript, at least within one organization, and I believe the others are pretty much doing the same. So within Europe, if you come from some department and it will say data science on the transcript, we want to make sure that we agree on what that represents, and that across Europe, at least we know, and we have one definition of data science. And hopefully we can, of course, refine that, and as we see what others are doing, we can kind of have a similar definition go to the higher level. But at least we're trying to do this within the university. So it's not the case that if I have this department do some kind of data science, this department do very different kind of data science, and no one agrees. So at least within a university, we can get together and try to have some agreement. But I think it's pretty early to have this completely defined at the top level.
So what I'd say an argument in favor of a degree or even something more structured is that in university settings, the power is really derived at the departmental level. And until there is a department, one could make the argument that because it's so matrixed out, you have to solve a lot of dependencies across all these different majors. So the Data 8 program, for instance, is now considered a satisfaction of the stats requirement in a large number of majors, but not all of them. And one of the benefits of having a department of data science of some sort is that it would get to define it for its own needs. I mean, also very practically, it's the place where funding comes in, right? Mm-hmm. So if you have a department there, that department can do fundraising for the specific needs. So there are arguments to be made for that. Again, the danger, I think Magda was hitting upon that, is that there are so many requirements of students if you are going to create sort of a bona fide data science major. And some of that depends upon what you want to do in those domains. So you'd want students to be spending time in other departments as well. So it is a grand challenge.
Agreed. Oh, sorry. Then you.
I'm Patty Ordonez from the University of Puerto Rico. We have a data science track that is interdisciplinary, so that people from the sciences have, you know, certain prerequisites that are different from people in the math and statistics, so that they can all talk to one another. And that's my first question. Like, what do you think about something of that nature? And then the second question is, in terms of data science, and especially now with big data, I've seen this trend, and I guess this kind of goes with the ethics. I've seen this trend where, okay, somebody says something happened to them, and I'm thinking in particular of the vaccines right now, right? A lot of people are saying that something, you know, they know that their child got autism from the vaccine, but there's all this data that proves that it didn't. And but at the same time, as I'm looking and hearing this, and I see the videos of these people, I know that all this big data stuff is probabilistic. It's not deterministic, right? So it could be that for that particular person, it's not, and it kind of bothers me to see all these people saying that these people who are complaining about the vaccines are anti-science, when I really think they're just basically trying to get answers to science, and to some extent I feel like if we all start believing that data science, because it's big data, is fact, as opposed to like listening to the people who are having these issues, we're going to face a problem. And this is something that I think would be wonderful for an ethics track. And I wondered what you guys thought about that.
So when we first developed the fourth paradigm, the vision behind that, it was funny because I once was at a conference where someone was saying that it was the nail in the coffin for science. Science is dead. And the fourth paradigm is the one who said it. And I said, I think actually that was a Wired article. Because it was a Wired article that said science was dead.
End of theory.
Yeah,
article,
the end of theory, right. Which is the exact opposite. I don't think that you can do science in a vacuum. And the reason we chose for that particular book to partner a computer scientist with a domain scientist was because if you don't have someone in the domain, it's to fact check what comes out of that big data, you're basically just doing pop science. You're not doing real science. So I only want to say that I completely and wholeheartedly agree with that.
I mean, again, from just the data literacy perspective and with that lens of what you would hope to teach people before they got out of an undergraduate education. And by the way, you could imagine even pushing that farther down into the high school education or lower. You would teach about correlation and causation, not just in the context of big data, but what it means for things happening in people's lives. And you obviously couldn't educate a population so much that they would disregard what they wind up feeling, but you at least would arm them with, arm them with the ability to think critically about the problem for themselves and for the society. So again, I think that the example that you brought up around autism and vaccines is a great, potentially even classic example of how people can wind up understanding what's happening in their lives given what they know about what's happening in the aggregate.
Yeah, well, statistics I think is a good part of it. So causation and correlation is one. The idea of error bars and the fact, being able to know how much confidence you have in whether what you're predicting is correct or not is important. But I think that's in general hard for the general population to wrap their head around. And so the idea of having some kind of storytelling, especially around hard problems, so that or climate science and what's happening right now with climate change, again, could be a place where if we have the right kind of storytelling going on, say even a mix between journalists and data scientists and scientists, that this could be helpful.
So I actually think that your question raises two very interesting points that I think are complementary to what has been said. The first is it actually tells us that we need to push data science at the high school level, because we have to push data science literacy to the level that everyone in our society will have, those people who will vote will have. And I think at this point, maybe high school is kind of the level that we should target. And I know that some high schools started to do it, and I think this is just very important to define what do we need to teach at that level to have kind of the next generation of citizens. And I think this is a problem that's very solvable. But I think there's a complementary problem, which is how about all those people who already graduated? They are going to be around for the next 80 years, and they did not receive that education. And I think this is a huge problem in society in general, is that we educate the next generation, but what about all the rest? I guess all the rest of us who already graduated, and here people will need some kind of education to understand all of these conclusions, all of these articles, and everything that's happening, and also vote accordingly and make decisions for society accordingly. And I don't have an answer here. I just think this is a very important problem that hopefully someone will, maybe one of you in the audience will have a good idea about.
We're actually, we have one more question, and we're going to run a little bit over. We started a little bit late so we're just running a little bit behind. But right here, could you give him the mic, and then we'll wrap up the session.
Do we not have till 2:30?
I thought.
We may want to check on that.
Am I mistaken?
I just don't want the conversation to end.
Oh yeah, I know. Well.
Do you have questions also in that?
Can somebody look at their schedule?
Okay, great.
Good.
We have lots of time for questions. Okay, sure.
Right.
I'll start leaning this way.
Excellent. So I'm Mesh Saker from Carnegie Mellon, and we do have a master's in computational data science program. That's a collaboration between the computer science department, a language technologies institute, and the machine learning department. We actually offer it as 3 majors, one in analytics, that's mostly what you're covering. Another is in systems, which is the systems that enable data science. And the third is in human-computer data science. But that's my question. I just wanted you to know, and we can have discussions about this in the future. My question for the folks who are in academia, are you thinking about offering any of your programs as distance learning programs? And for those in industry, how do you react to people who have been trained using distance learning programs, and do you use any technology currently in training your current engineers?
So
We'll let them go, and then.
yeah.
Sure.
We do currently have a MOOC out on data science, which is a sort of a higher level one with many modules. I think we have 14 modules from different faculty who teach in that area. We're working to get our certification program online. That's a program that is intended for working people who need to have more data science in their job. I think as anybody in a university knows, that requires some administrative hurdles to get through. So we're in the middle of that, but that's what we're planning.
I've got a lifeline that I can call into. Dave Culler, who joined us, one of my colleagues who has been very much involved in the data science education initiative at Berkeley, may be able to speak to this question about distance learning.
Do we have another
Sorry to
mic?
put you on the spot there.
You want me to try that?
Sure.
So I'd say, is that live? So I'd say we've started by focusing internally because, nail it before you scale it. All of the conversations we've had suggest it needs to grow to that. We're finding in general the techniques that you develop for online education and whatnot have a role to get more of a kind of mastery feedback, and that's really important in this space. So I'd say we certainly see it as a thing down the road, but every conversation we have brings back the question, the generations that have already gone through, which translate into executive ed or this or that. What's not at all clear is that masters is what those folks care about, and I think we have to get a little past the normal 1, 2, 3 we seem to deliver as degrees and think a little more openly about it.
So I think we're kind of in a similar situation where we have MOOCs on introduction to data science, MOOCs on machine learning, etc. But I think bridging the gap between, so we know how to do daytime programs and certifications, and we know how to do MOOCs, but how to do MOOCs and certifications, I think it's also remains to be resolved.
So from our perspective of training internally, we have quite a number of our data scientists / engineers who have gone through Coursera for online training. Johns Hopkins and a few others that offer courses in data analysis, statistics, machine learning. And frankly, it's a way to up skills. And for most of the team members, that's more important than the next degree. And so they've kind of focused on tactically the specific courses that will help them up their skills and apply it to the kind of work that we do. So that's one way we're addressing. I forget who raised this sort of general issue of literacy. You know, our CEO kind of laid down the line, which was like every engineer in the company needs to become literate around statistics and working with data, because that's where we're going culturally. And so, you know, we fully embrace that in the Windows and Devices group. My team's created a lot of training just for the division, recorded sessions that we do, brown bags and things like that is one mechanism. And we also really push storytelling by sharing insights that we've gained through data analysis. And we publish a weekly newsletter. It goes to about 3,000 people in the company. And it's all about anecdotes and insights that we've gained as a team.
So there's because of the gap, in fact, I really want to focus on the gap, because what's happening really is that we have some extremely brilliant people, many of them hired from your institutions, but they have already been out, and they are not data scientists. And so they struggle when we need them to actually, you know, in this company where we have now embraced data to such a degree that it's part of everyone's job. So we offer our own certification program internally through our Microsoft Learning Network, which is not a MOOC, but in-classroom courses that are taught by various people who are data scientists around the company, many of them actually new to Microsoft, coming from the disciplines themselves, who actually do teach. And at the end, in fact, if there were a way to get it certified beyond just our own internal certification, that would be fantastic. In fact, we're looking for a partner. The other thing that we do is we have 2 conferences, and they are available to Microsoft FTEs only. One of them is called the Machine Learning and Data Science Conference. That's hosted by my organization, the Data Science Group, and another one called One Analyst, which is for more of the people who are day-to-day analysts inside of the company. And again, these are closed to the outside. They are actually internal conferences where only Microsoft employees come to them. And they are for scaling up our knowledge about data science, because this is the gap. It's not only hard to hire people, we already know that we have brilliant people working here. The challenge, the biggest gap I see is that we're leaving people behind. People who really, truly want to either re-educate or advance their careers. They already have a degree. So getting another degree is just not relevant to them. And they don't want to quit their jobs either. They want to be able to maintain themselves in role, be successful in role, but at the same time, maybe start considering other options.
One of the things I just want to emphasize in this conversation is that obviously it's not the only goal of the university mission to produce people who are going to be great in industry. There's a self-preserving role of creating more great scientists and computational thinkers who can push the envelope within academia. And that's something that a number of institutions are struggling with, is how we find places for them, not just on the educational side, but just from a careers perspective. The more on the Sloan Foundation granted to UW, NYU, and Berkeley a fairly substantial grant, which will be lasting over several years, to help us work through that at some level, to try to understand how we can change the culture within departments, within campuses, to create careers. And it's almost the opposite challenge. We've got people who are fantastic data scientists, and for whatever reason, they can't imagine being in industry. They love whatever it is that they can do in an academic environment, and are struggling to find a place for themselves where they can wind up contributing there, and then also train the next generation. Because of course, if we basically admit all these great people into industry and we don't have a way to continue training at the university level, we've got a big problem. But Ed Lazowska, who's here, spearheaded that from the UW. Jan LeCun at NYU, and Saul Permuter at Berkeley were instrumental in that. And Magda and I were on our respective university grants for that. So we've been thinking about this for a while.
Okay, so I've been ignoring the side of the room. Please, the back.
University. I'm an economist by training, and so we've been doing data for a long time as economists, and we have we're not at all model agnostic. We think very much about the structure of the model. We worry about collinearity in the data and how that might give the right parsimonious model to give an explanation. Our agents are strategic, and so there's questions of endogeneity, questions of adverse selection, moral hazard. Time series, the structure of that makes a big difference, thinking about possible causality and also the structure of the errors. And my experience in looking at this data is that if you don't ask the data the right question in the right way, the data will lie. So it's not really it's just science. It's really the way the question is asked. So my question is, to what degree do you take these kinds of considerations, endogeneity, regime shift, the fact that agents will behave differently in different environments according to the question presented to them, how does that figure into your conception of data science?
So, I mean, I think it's very much co-aligned with that conception, teaching people to ask the right questions and to give them the tools to be able to apply the right statistical method at the right time and be able to call BS on themselves when they get it wrong. It's even, but data science is even bigger than domain-specific, methods. There's also issues about, teaching people how to work collaboratively in an open source environment. Reproducibility is another big theme, and in economics, as you know, that's been a big issue, as it is in many different sciences. So. Bringing to bear a number of different ways to think about data into any realm, economics, ecology, and beyond, is, I think, a big part of that mission. And the challenge, again, coming back to the fact that we have these boundary conditions of there's only so many credits that a student can take, is how do you get them proficient at the core level, but then get them good enough in the domain, like economics, so that they can even learn to ask the right questions and be skeptical when somebody else tells them the answer.
I think at the same time, it comes back to something that we talked about very early on the panel, which is that you cannot have one person working alone on a problem. You should not have one person working alone on a problem. I mean, the breadth of data science is so large that someone who is proficient at all the technical aspects of data science is probably not going to be good enough to do econometrics. So the important thing, either the pairing that they're doing at Columbia or the partnering across departments that's happening at UW and at Berkeley, I mean, these types of things are where you're going to prevent that. You have someone else to call BS on the outcomes. I think that, again, like when I'm going to hire someone, if it's someone who's just really good and can sit in a room by themselves, that's not somebody I'm actually really interested in hiring. I want to know how they've worked with others and how they continue to partner to actually come to the conclusions.
Yeah, I actually think this is a place where there needs to be more depth on the foundations and in the statistics and on the technical side of things. And it's possible to cover a certain amount of that in the introductory courses, but it may be a place where, there needs to be a little more depth in those areas.
Hi, Jevin West from the University of Washington. So I can't tell you how many conversations I've had in my office with students at the undergraduate level, master's level, PhD. They all want to be data scientists. And I really don't feel like I'm giving a very nuanced answer, because I say the same things that we've been saying. You need to know a little bit about machine learning, you need to know a little bit data management, so on and so forth. So I would love the industry, Kristen and Rob in particular, to help me give a more nuanced answer. But here's the interesting thing. I also have many of these PhD students. I just recently was mentoring an astronomy student and a biochemistry PhD student. They said, I want to be a data scientist. And then I get a call a few months later and they said, guess what? I got a job at Microsoft. And so I'm wondering, is the system already working fine? Because I spend all this time with Magda and others at UW. We're trying to build this PhD program for data scientists and master's program, but they're getting jobs there. Is it because there's no one else to choose from, or is the system actually even working? So there's my provocative question.
Yeah. So we need data scientists, and we need those skill sets, and we will find them no matter where you hide them. And that was sort of what I was trying to say earlier, is that like 3 years ago when I would go on campus, I would find the skills that I'm looking for, and we talked a lot about them, and largely through the engineering computer science programs, maybe through math and statistics programs. And then over time, I'm seeing more and more of that in other areas. And do they have everything? No, they don't. And that's kind of okay, because we know we're not going to get that perfect candidate. And look, we have needs to fill. And so some of it is we'll take the right combination of people and build a portfolio of a team, because like Chris said, we don't ever really put one person on a project. We cross-staff, we put people together for a bunch of reasons, not just that they have the combination of skills, but it creates learning opportunities. So you have somebody who really wants to learn how to apply machine learning for predictive type problem. You put somebody who has got the experience and expertise, and that's an opportunity for that person to learn and grow as well.
I love the comment that we'll find him wherever you hide him. Because the reality is that some of the best data scientists that I've interacted with were people who worked on this project I did at the National Flood Interoperability Experiment. Civil engineers, hydrologists, atmospheric majors. They were all PhD students who participated in a summer institute that was held up by NOAA. The fact of the matter is that what I see as a gap for someone who's just a pure data scientist, they put "I'm a data scientist" on there, is that they lack a grounding in something real. So if someone is a physicist, an atmospheric scientist, an astronomer, the chances are that they have this concept. I was actually I was on a panel with Magda last summer, I think it was, and the person next to me, also from a different from an industry but from a different company, said, "Data science is just statistics," and I just could have gone because that's the, in my mind, some of the greatest minds in data science are being used for ads. And the reality is that problems are hard, and where you're going to find someone who really understands what Rob is saying when he says 80% of the time is getting that data together and cleaning it and making sure that it can actually be used for prediction. That's the same problem we have inside of the company with our data. And sometimes the only people who are really going to understand that is an oceanographer who had to go out and collect data with John Delaney and come back and try and make sense of it. So a lot of times I would just say it's, I would want someone to be grounded in real world problems. So yeah, I'm going to go ahead and hire that oceanographic person or atmospheric scientist, largely because I know that they can do real data scientists. They have a sister discipline that they can show where they've actually done this in the real world.
There's this kind of intangible thing that we talk about on the team that we call ruthless curiosity. And we look for it in the people that we hire. And often we do find it in people who have some deep domain expertise that might be outside our immediate area. And then we go for that.
Yeah, absolutely.
So I would like to actually raise a question following Jevin's question. So if someone comes to my office and they're a first-year biologist, a first-year PhD biology student, they say, I want to become a data scientist and work for Microsoft when I graduate. Well, I know how to advise them. I'll say, well, in the context of your current degree, make sure to take the following courses that will teach you all the foundations of data science, and you'll have all the skills. But if someone is already late in the program, let's say someone in their last year of their PhD, or they're currently doing a postdoc, they decided, you know what, I don't really want to become a faculty in some domain, right, in astronomy or in biology or something. I would rather actually go and become a data scientist in industry. Then what advice would you give them? They're kind of, in their last year.
I would ask you to pick up the phone and say, Chris, I have a really great intern for you.
In the conversation with that candidate, I would want to hear about the kinds of problems that they have worked on and solved. What what did they do to get the data that they needed to answer those questions? How did they clean the data? What analytical methods did they use to answer their questions? You can learn an awful lot about the potential to apply the skill set in our domain from a 30-minute conversation of that nature.
There's one back there.
Hey, I came in a little bit late to the session, so I apologize if this has been asked already. So one of the things that comes up often for us internally is questions of ethics, not just in terms of privacy, but also in terms of security, discrimination, and online experimentation. One thing we would love is for us to have people who are trained in data science, but also the ethics of data science. And so I don't know if that has come up already, but I'm wondering if folks can touch upon how this is being integrated into the curriculum so that we don't have to resort to people who actually don't have any grounding in human subjects research or that sort of thing, which results in really terrible situations.
It has come up, but I mean, we could probably do a recap.
So maybe a brief recap. So at UW, the way we try to tackle this very important challenge is in all our degrees. So we already have the advanced data science at the PhD level, and we have a data science at the PhD level. We require that students take a certain number of quarters of the eScience community seminar. At the undergraduate level, we require that they take 1 quarter of a seminar called Data Science and Society. And in both, we cover, I would say it's kind of like the making people sensitive to these issues session. So for example, this past year, we had one faculty come and talk about all the negative results about data anonymization, how it's actually really hard, and how most of the time you can't really anonymize the data, and this is a hard problem, and issues related to repetitive hypothesis testing and other such issues. So that's how we are tackling this problem right now.
We have a lot of interest in these issues. We don't have a course on ethics in our data science masters, but we do have a lot of interest in these issues in schools like the law school or the School of International and Public Affairs, and they do have courses that are relevant. As part of, I also lead the Northeast Big Data Hub, and we have a spoke there on ethics, which is looking very much at how it can engage with people from different areas of data science, so security, health, and so forth, and in the education spoke on how to bring ethics across the board in data science.
Yeah, and the only thing I'll add to that is that I think ethics, privacy, and security need to find its way into the core canon of what undergraduate data science education is. And for those who are creating these programs, hearing again from industry that this is important, and this is something that you'd like people not to be completely green on when they show up on their first day, helps us in formulating what our program is.
Other questions?
So my name is Asafoy. I'm from Washington State University. We have a data science program that we're starting in the computer science department, and I'm involved in it. The challenge I have seen is it's easier to do at a graduate level than at an undergraduate level. And the kind of things that are lacking are easier to build into somebody who has had a degree somewhere and you are missing a gap. But it gets harder if you are to actually define things and say this is a major. Do those people who have in education found that thing to be a strangely difficult thing to do, something at an undergrad level than it is at the graduate level?
So we have done less on the undergraduate, but we do have an ongoing major, which is joint between computer science and statistics, which we are reshaping as a data science major. I think one of the tricky parts of it is going to be how to bring in other disciplines as part of it.
So I think for us, the proof is in the pudding. We've already had a PhD data science program approved 1.5 years ago, and we still have the paperwork pending for the undergraduate, so definitely took us longer. What we find for the graduate level is everyone is excited, everyone is open, and there is sufficient flexibility in all the PhD programs that people can fit in the data science specialty by saying, well, just take these classes instead of these other classes. So very doable. At the undergraduate level, everything is so packed that it's extremely difficult to find things to remove in order to put the data science in. And as a result, undergraduate programs that are methods focused, like information school, HCDE, applied math, etc., computer science, have an easier time adding a data science specialization. And other programs that are really, social sciences, biology, they're so packed that it's a deep conversation to how to make all these changes happen. So I just strongly agree with you that yes, this does seem to be kind of by level of difficulty, grad is easy, undergraduate in methods, doable, and undergraduates in other areas kind of remains a work in progress.
Yeah, and just to summarize, at Berkeley, we've now started focusing on the foundational course, basically, that's meant to attract all undergraduates, or at least could be taken by all undergraduates. And that then will be taken concurrently. I think there's 16 courses or so in this upcoming semester with other departments. So these are called connector classes, where the domain-specific needs are addressed in more detail. And then there's extender classes where people wind up going into more depth. And then there's modules that can be embedded into existing classes. This is all sort of prelude to what could become a major and/or a minor over time. But it's more of a ground-up thing rather than say, let's just declare that we're having a major. Basically building classes, cutting teeth on that, understanding the resonance that we have with students and what their interests are going forward after that.
And I would like, so Josh's comment reminds me that the place where we find the most success in introducing data science in different departments around campus is whenever that department hires a faculty who's partly data science, part that domain. So at the University of Washington, we had several faculty who have been hired specifically because they're at the boundary, and these faculty are really instrumental in making the change happen in their home departments. Because they are from that home department, they speak that language, they understand the department, and they are the ones who are kind of adding these classes and making these changes happen, and that's been the most successful.
Okay, so we have one more question. I'd actually like to, it's the one question we didn't get to on the list, which is, when do we declare victory? And I'd like each one of the panelists to describe what their nirvana state is. Like, how do you know you've been successful? Josh?
Starting with me at the end. So, I mean, in any academic institution, there is never a victory in a sense that you've solved all the problems, right? And from an educational perspective, so that's on the research side. So I don't think we'll ever get there, and that would be a good thing, because if data science actually is a real science and it does have the notion of what a PhD should be behind that, then there's going to be a large amount of time when this is relevant for research. So that's the statement on the research side of things. On the teaching side of things, students vote with their feet, and if they're showing up in droves to these classes, and people are generating the interest that we see already happening from some of these intro classes, and carry that on with them and beyond. Again, I started off this conversation with what that 2020 vision is, which is now a top-down one, but started really from the groundswell from faculty and students, is that we will have declared victory when we're all very confident as educators that students can formulate questions around data, can be critical of answers produced on data and analysis by others, and then become informed citizens. And so, that's the grand vision. I think we'll wind up getting approximately there at some point, but we'll never obviously achieve it.
So that is a hard question, I have to say. I think it does depend in part on interest, that it's sustained over time, that we continue to have a demand for data science from students who come in, and that students who go out are placed in positions or in research that they find rewarding. I think we're also successful when we do have that outreach to different disciplines, and when we are able to help in either educating people from very different disciplines, or in helping them to learn how to use the tools so they can solve problems themselves.
So I think all I can do is just echo these great comments that at universities are just in constant evolution. And I think all of us who are teaching, we see that every time we teach a class, it's always different. All those programs change continuously. So I think we'll always be in this mode of constant change and constant innovation, which I think is very, very important. And each change that we make, how do we know that this is a beneficial change? If students actually show up to the classes, if students are happy with those classes, if students after they graduate, they come back and tell us that these classes indeed were useful to them. So we need this feedback loop from the students, but this is something we have always been doing and we're always going to do, whether it's called data science or something else. This is just constant.
Yeah, it is a tough question. You know, at Microsoft, we've been hiring software engineers for 35, 40 years, and I'm not sure we would declare victory on that in terms of a perfect process of landing the best talent consistently in the organization. And so we're in a pretty early phase in the journey when it comes to the cultural evolution. And you know, we've had a data science career discipline at Microsoft now for 2 years.
2 years.
And so it's pretty early days for us.
Yeah, it's a new title now to be a data scientist at Microsoft. I think the only thing I would echo as well is actually something you said, Kathy. Ultimate nirvana for me is that we have a group of people who are happy doing what they're doing in data science. Like if I could pick one thing that I would like is to find folks who really enjoy it, love it, in fact, not just enjoy it, but are passionate about it and really want to contribute and be really good at solving real world problems. Okay, well, thank you everybody for coming to our panel.
Nice to meet you.